Hello everybody, welcome into another lesson. So today we're going to talk about solving quadratic equations by using the quadratic formula. And this formula, as you're about to see why, I would highly suggest using this as a very last resort. Like if you can't factor an equation, if you don't have any perfect squares, if completing the square will involve fractions, then I would default to the quadratic formula. I mean, you can use the quadratic formula on any quadratic equation, that's fine, but it is not very pretty. But of course, by now we're all familiar with the general form of a quadratic equation, ax squared plus bx plus c equals 0. Well, to find your values of x, you're going to take the negative of that b and then do plus or minus the square root of b squared minus 4ac all over 2a. So yeah, that's not a very pretty formula, is it? But it does work to solve them. Let's go ahead with the first example here. So we have x squared minus 3x minus 10 equals 0. So today we're solving using the quadratic formula. So we have x squared minus 3x minus 10 equals 0. Well, your x, that's going to equal the negative of your b, which b is negative 3, so negative 3, that's positive 3. You would do 3 plus and minus the square root of that b squared, which is negative 3 squared, minus 4 times your a, which is 1, times your c, which is negative 10. You're going to put all that all over 2 times your a, which is 1. So now you're going to have 3 plus and minus the square root of, let's see, negative 3 squared is 9. The negative 4 times 1 is negative 4 times negative 10. That's plus 40 all over 2 times 1, which is just 2. Alright, so now this will translate into 3 plus and minus the square root of 49 all over 2. Which we know the square root of 49 is 7, so this will become 3 plus and minus 7 all over 2. And we have two roots, right? Because you have plus and minus. So now, let's go in the numerator. If you do 3 minus 7, that gives you negative 4. Take negative 4 and divide that by 2, you'll get negative 2. And then if you do 3 plus 7, that gives you 10. Divide that 10 by 2, you get 5. So this one actually wasn't terrible, but it would actually turn out this does factor. So we could have factored, but we're trying to demonstrate the quadratic formula today. So we're only using that today. So x would be equal to negative 2 and 5. Those would be your values of x that would give you 0. For the function. So this proves the quadratic formula works for whether you can factor or not, but it's particularly useful if you can't factor the equation. I'm going to keep that quadratic formula up there so it's there to reference, because it is kind of a big formula. Alright, what's the next one I'd like to do? We have 2s squared minus 3s minus 2 is equal to 0. So we got 2s squared minus 3s minus 2 equals 0. So let's do our quadratic formula here. X is going to equal the negative of b. Well, b is negative 3. Negative 3 is positive 3. So you have 3 plus and minus the square root of that b squared, so that'd be negative 3 raised to the second power minus 4 times your a, which is 2, times your c, which is negative 2, which would now be all over 2a, which a is 2, so that'd be over 2 times 2, which means you're going to have 3 plus and minus the square root of, well, negative 3 squared, that's positive 9. And then negative 4 times 2 is negative 8 times negative 2, that's positive 16. So you'll have 3 plus and minus the square root of 9 plus 16 all over 2 times 2, which is 4. Which now you're going to have 3 plus and minus the square root of 25 all over 4. So now we know the square root of 25, well, that's 5. So you'd have 3 plus and minus 5 all over 4. Alright, so we know x again is going to have 2 values. Let's do 3 minus 5. 3 minus 5, that's negative 2 divided by 4. That'll give you negative 1/2. So negative 1/2 is one of your answers. Then 3 plus 5, that's 8, divided by 4 is 2. So the values of x for this particular function are going to be negative 1/2 and positive 2. Alright, let's see. We have 5z squared minus 11z plus 2 equal to 0. So we've been given 5z squared minus 11z plus 2 equal to 0. Well, let's do our quadratic formula here. We have z is going to equal the negative of b. Well, b is negative 11, so negative 11, that's positive 11. Then that'll be plus and minus the square root of your b squared, so you would raise negative 11 to the second power minus your 4 times your a, which is 5, times your c, which is 2. This would all be over 2 times a, or 2 times 5. So there's the plug-in for the quadratic formula. So now we're going to have 11 plus and minus the square root of all this mess. Negative 11 to the second power, that's positive 121. Then you have negative 4 times 5, that's negative 20 times 2. That's negative 40. All over 2 times 5, which is 10. Okay. Well, now we're going to continue this further. We have 11 plus and minus the square root of 121 minus 40. That's going to be the square root of 81 all over 10. So we have 11 plus and minus the square root of 81 over 10, which means this would be equal to 11 plus and minus 9 all over 10. So now we know z has 2 values, right? Let's start with 11 minus 9. 11 minus 9 is positive 2. Then over 10, that turns into 1/5. So one value for z is going to be 1/5. The other value, let's see, so 11 plus 9, that's 20, divided by 10 is 2. So the 2 values of z that you're going to get are going to be 1/5 and 2. Those would be your answers for z, 1/5 and 2. So I think you're all beginning to see why this is not the most preferred method for solving quadratic equations, but this is a very critical one to teach because this is going to carry with you throughout your future in math. So I hate to say it, but get used to it. Okay. Next, we have 2y squared minus 6y minus 8 equals 0. Well, we can stop here to start with. You notice every single one of these terms is divisible by 2. It is okay if every single term is divisible by a common factor to do that. So if we divide these terms by 2, you'll end up getting y squared minus 3y minus 4 is equal to 0. Now that's much easier to work with. You're going to work with smaller numbers as opposed to if you would have kept the original. I mean, you can keep the original, but why torture yourself? Why would you want to do that to yourself if you don't have to? So now we can work with y squared minus 3y minus 4. So let's set up our quadratic formula. Y would equal negative of b. Well, b is negative 3, so negative 3, that's positive 3, plus and minus the square root of your b squared, which would be negative 3 raised to the second power. All that minus 4 times your a, which is going to be 1, times your c, which is negative 4. All that's going to be over 2 times your a, which is 1. So now we've set up our quadratic formula for this, which this will simplify further into 3 plus and minus the square root of negative 3 squared. That's going to be positive 9. Then we have negative 4 times 1 is negative 4 times negative 4 is positive 16. So now this has simplified, and then 2 times 1 is 2. This is simplified into 3 plus or minus the square root of 9 plus 16 all over 2. Which this will simplify even further into 3 plus and minus the square root of 25 all over 2, which means now we have 3 plus and minus 5 all over 2. Okay, which means y has 2 roots, has 2 values. So 3 minus 5, that's negative 2 divided by 2, that's going to be negative 1. And then 3 plus 5 is 8 divided by 2 is 4. So the two values you get for this equation are negative 1 and 4. That's what y would equal, or negative 1 and 4. Now, if you would have kept the original equation and not factored out, you would have got the same results. You just would have worked with some bigger numbers. And again, why do that to yourself if you don't have to? Let's see. We got z squared minus 5z minus 6 is equal to 0. Okay. Well, we'll set up our quadratic formula here. Z is going to equal the negative of b. Well, b is negative 5, so negative 5, that's plus 5. That'd be plus or minus the square root of that b squared, so you would take negative 5 to the second power minus 4 times your a, which is 1, times your c, which is negative 6. This is going to be all over 2 times a. Your a is 1, so that'd be over 2 times 1. So now we've set up your quadratic formula. This will simplify into 5 plus and minus. Alright, negative 5 squared, that's positive 25. Then negative 4 times 1 is negative 4 times negative 6, that's positive 24. All over 2 times 1, which is 2. So now we have 5 plus and minus the square root of 25 plus 24 all over 2. Which would simplify further into 5 plus and minus the square root of 49 all over 2. Which simplifies yet further into 5 plus and minus 7 all over 2. Alright, so that means z is going to have 2 roots. Well, 5 minus 7 is going to be negative 2 divided by 2. That's negative 1. Then 5 plus 7 is 12 divided by 2. That's 6. So your roots for this, your answer rather, so the answers are also called the roots. Z is going to be equal to negative 1 and positive 6. Now, if you're just taking one algebra course, you don't need to remember this then. I mean, you might want to study this formula, but if you're going further into like Algebra 2, pre-calc, calculus, and even beyond, commit this formula to memory. I'm telling you, it's really going to help you. Alright, let's see. Different one. We have m squared plus 8m plus 7 is equal to 0. Okay. So we have m squared plus 8m plus 7 equals 0. So let's set up our quadratic formula here. M is going to equal the negative of b. Well, b is 8, so you'd have negative 8 plus and minus the square root of b squared, which would be 8 squared, minus 4 times your a, which is 1, times your c, which is positive 7. This is all going to be over 2 times your a, which is 1. So now we've set up the quadratic formula structure. This will equal negative 8 plus and minus the square root of, let's see, 8 squared is 64. Then negative 4 times 1 is negative 4 times 7. Well, that's going to be minus 28. So we have the square root of 64 minus 28 all over 2 times 1, which is 2. So now we're down to negative 8 plus and minus the square root of 64 minus 28 all over 2. Which this is going to simplify further into negative 8 plus and minus the square root of 36 all over 2. Which means this equals negative 8 plus and minus 6 all over 2. Yeah, you see, quadratic formula can get rather long. That's why this is not a preferred method. We definitely could have factored this. I know that would have factored into the quantity of m plus 1 times the quantity of m plus 7, but we're not doing factoring today, so... Alright, m has 2 roots. Let's start with first negative 8 minus 6. That would give you negative 14. Then divide that by 2, you would get negative 7. And then let's do negative 8 plus 6. That would give you negative 2. Divided by 2 would give you negative 1. So your answers for m are going to be both negative 7 and negative 1. Those would be your answers. And of course, if you're ever unsure, you can stick both of your answers into the original equation and you should come out with 0. That's exactly what you should come out with. Alright, let's do a few more here. Let's do about 4 more, okay? So we have j squared minus 6j equals 13. So we have j squared minus 6j equals 13. Well, this one looks nice enough where we could complete the square. And we could. We could do this by completing the square, but today we're only focused on the quadratic formula. So first thing you want to do is get that 13 out of the right hand side, make the right hand side equal to 0. So you would subtract 13 from both sides. which we end up giving you j squared minus 6j minus 13 would be equal to 0. Now we have the equation in proper quadratic form. We have a standard quadratic equation in standard form. Now we can start solving for j. So j is equal to the negative of b. Well, b is negative 6, so negative 6, that's positive 6, plus and minus the square root of your b squared, so you would take negative 6, raise that to the second power, minus 4 times your a, which is 1, times your c, which is negative 13. Alright, this would be all over 2 times a, which a is 1, so that'd be over 2 times 1. So now we've set up our quadratic formula, which this will simplify further into 6 plus and minus the square root of, let's see, negative 6 to the second, that's going to be positive 36. And then negative 4 times 1 is negative 4 times negative 13, that's positive 52. This would be all over 2 times 1, which is 2. Alright, so this will simplify yet further into 6 plus and minus the square root of, see, 36 plus 52, that's going to be 88, all over 2. Well, we definitely have our first one here that's not a perfect square, because 88 is definitely not a perfect square, right? But we know the factors of 4 and 22. We know 4 is a perfect square. So this will equal 6 plus and minus the square root of 4 times the square root of 22 all over 2. Well, this turns further into, let's see, we have 6 plus and minus, let's see, square root of 4 is 2 times the square root of 22. Square root of 22 doesn't factor any further. This will all be over 2. But do we notice between both terms in the numerator, you can divide out a common 2. So that means j is going to be equal, see, 6 divided by 2 is 3. And then 2 times the square root of 22 divided by 2, this is going to be plus and minus the square root of 22. So the answer for, you have two answers really for j. J is equal to 3 plus and minus the square root of 22. That would be your answer. So yeah, not a pretty answer, but it definitely works. It's definitely the right answer. And if you want to have fun putting these into the equation to check, be my guest. I don't think you want to. So 3 plus and minus the square root of 22 is your answer. Let's see, we have 4y squared minus 12y is equal to negative 7. Alright, so we have 4y squared minus 12y equals negative 7. Well, we definitely want to get that negative 7 out of the right-hand side, make the right-hand side equal to 0. So you have to add 7 to both sides in order to do that. So when we do that, the equation you'll get would become 4y squared minus 12y plus 7 would be equal to 0. Now this quadratic equation is in the standard form, which means we now may begin doing the quadratic formula. So y is equal to, alright, negative of b, well b's already negative 12, so that means negative 12, that's positive 12, plus and minus the square root of b squared, so you would take negative 12, raise that to the second power, minus your 4 times your a, which is also 4, times your c, which is 7, this is going to be all over 2 times a, which in this case is 2 times 4. So this one's definitely not so pretty. Which this will simplify into, let's see, 12 plus and minus the square root of, let's see, negative 12 to the second, that's positive 144. Then you got negative 4 times 4 is negative 16. Then you have negative 16 times 7. Let's go ahead and take that here. That'd be negative 112. So you would end up now with the square root of 144 minus 112 all over that 2 times 4, which is 8. So your denominator would have 8. Now we can simplify this further. This is going to be 12 plus and minus the square root of, let's see, 144 minus 12, that's going to be 32. So you have 12 plus and minus the square root of 32 all over 8. Which we know 32, granted, it's not a perfect square, not by any means, but however, 32 has a factor that's perfect, it's 16. So this is going to break down into 12 plus and minus the square root of 16 times the square root of 2 all over 8. Which we know square root of 16 is 4. So you end up having 12 plus and minus 4 times the square root of 2 all over 8. Well, we haven't reduced everything yet, okay? Which I'm going to give the final answer here in a minute. But we know between 12, 4, and 8, there's a common factor of 4 between those, right? So if we divide 12 by 4, you'll get 3 plus and minus. All right, 4 times the square root of 2 divided by 4, it's just the square root of 2 all over 8 divided by 4, which is 2. So your answer in simplest form, which it should always be in, is y equals 3 plus and minus the square root of 2 all over 2. So yes, that was not a fun answer to give, but y equals 3 plus and minus the square root of 2, all that divided by 2. Couple more problems I'd like to do. Alright. Actually, I think we'll just do one. I think one more problem would be sufficient. This time it's a little bit different. You have 4v squared is equal to 10v minus 5. So you have 4v squared is equal to 10v minus 5. Well, we want to make the right side equal to 0, don't we? So that means we have to subtract 10v and add 5 to both sides in order to make the right side 0. So if we do that, you'll get 4v squared minus 10v plus 5 is equal to 0. Now this quadratic equation is in standard form. We can proceed with the quadratic formula. So v equals the negative of b. Well, b is negative 10, so negative 10, that's positive 10. That's going to be plus and minus your square root of b squared, which would be negative 10 to the second power, minus 4 times your a, which is also 4, times your c, which is positive 5. This is all going to be over 2 times a, which is 2 times 4. So now we've at least set up the quadratic formula for this equation, so we can start simplifying further now. This will equal 10 plus and minus the square root of, let's see, negative 10 to the second, that's positive 100, All right, then negative 4 times 4, that's negative 16 times 5. This will be minus 80. So we have 10 plus and minus the square root of 100 minus 80 all over 2 times 4, which is 8. So we're down to 10 plus and minus the square root of 100 minus 80 all over 8. Well, this will simplify yet further into 10 plus and minus the square root of 20 all over 8. So we're getting there, but we're not quite there yet. Well, granted, 20 is not a perfect square, but one of its factors is a perfect square, the square root of 4. So what you'll have now is 10 plus and minus the square root of 4 times the square root of 5 all over 8. Well, we know the square root of 4 is 2, right? So we have 10 plus and minus 2 times the square root of 5 all over 8. But just take a look at this a minute. Is this in simplest form? No, because between the 10, the 2, and the 8, they all at least have a common factor of 2, right? So that means V, it's still going to have two answers. If we divide 10 by 2, we get 5. Plus and minus, let's see, 2 times the square root of 5 divided by 2 will just give you the square root of 5. This will all be over 8 divided by 2, which is 4. So now we have an answer in simplest form. The answer for V, it's really two answers. You have 5 both plus and minus the square root of 5 all over 4. So that's it for the quadratic formula. Next lesson, we're going to talk about something called the discriminant, which a preview of that is the discriminant is just that b squared minus 4ac portion without the square root. It's that portion of the square root formula. It won't necessarily solve the equation, but it'll tell you if you can expect 2 real solutions, 1 real solution, or 0 real solutions. So we'll get into that tomorrow. I hope everybody has a good night. Take care.